Okay, here we go, guys. 2.8. Now listen, you guys had a quiz on 2426. I gave those back yesterday. You have a test on Tuesday over 2426, 2728. We did 2.7 yesterday. We're doing 2.8 today. So your web assigns that are due on Monday, we're going to go over in class. That's going to be part of our test review. And then any questions you have from 2426 that you want to go over, that's going to be our test review. But your focus, a majority of your test is going to come from 2728, but it will have 26 and 24 stuff on it. But when we're talking about inverse functions, inverse is the opposite, guys. When we talk about inverse, the opposite of addition is subtraction, the opposite of multiplication, division. We're going to be using all of those inverse properties to algebraically solve for inverses, okay? We're going to get to graphing them and that sort of thing later on in different chapters, but right now we're focusing on algebraically inverse operations. What is very, very important for you guys to understand is our function notation is f of x. You guys have seen this a million times. F of x is a fancy way of saying what? Y. Okay, f of x is the same thing as y. If you are going to find the inverse algebraically and then tell me, hey, Mrs. Meadows, this is the inverse, your notation for inverse is f with a little -1 up in the corner like that. That's telling me this is the inverse. You have to have that on your answer when you guys answer your questions. That has to be there. Does everybody understand that? Okay, good. Very important. This has to be on there. If it's not, I'm going to take some points off. So looking at the definition of a function and its inverse. When you have a function and you have a domain and range, x value is your domain, right? Y value is your range. Your inverse function, the x and the y values switch. So x and y switch. They don't change signs. It's not that one's positive and it becomes negative or vice versa. They actually switch places. Your x values become your y's. Your y values become your x's. So in a case like this, right, if I have f of 1 is 5, f of 3 is 7, and f of 8 is -10. And they want to know the inverses. Well, what are my ordered pairs here? What ordered pairs do they give me here? Okay, 1, 5, 3, 7, right? And 8, -10. You knew that these numbers here were the x values because it's f of x. And then what you get out is your y value. Here is my x, here is my y. This is my f of x. This is my function. So if I asked you guys what the inverse function was, what happens with the x and the y values? They do what? They switch. So it would be 5, 1, 7, 3, and -10, 8. They don't switch signs. That would make it a reflection over the x or the y. They actually switch spots. Does that make sense? You guys see that? Okay. Now, when we talk about one-to-one properties, it means a function has to be a function in order for it to have an inverse, right? Your x values can't repeat, that sort of thing. Not every equation is a function, so not every equation is going to have an inverse. For what we're doing now, you will have an inverse to everything we give you, just to make sure that it works out and all that. We're going to talk about when stuff is and isn't. Things are inverses of each other. Yesterday we did our compositions. Remember, we did f of g of x, right? And then we did g of f of x. When you plug g into f, or when you plug f into g, did we get the same answers yesterday when we plugged one into the other? No. When you do get the same answer, when you do plug one into the other, and then do vice versa, and you get the same thing, that's how you prove that they're inverses of each other. Now, here's what I really want to focus on today, and this is what we're going to do a lot of practice with, is how to find an inverse algebraically, and these are the steps for it. We're going to go over this a bunch. You don't have to, this is already here written for you. But the first thing you're going to do algebraically is you're going to cross out the f of x and replace it with the letter y. Then you're going to switch the places of x and y. Then you're going to solve. Okay, I'm going to go through this with you, and you guys are going to be like, oh, I can do this. This is not bad. You're going to switch the places of x and y and solve. So let's do these examples together. All right, I have a bunch of examples. I added some extra to your notes just to make sure that we have plenty of practice. But if I give you an equation and I say, here, find the inverse, I'm letting you know there is an inverse. So algebraically, you're going to find it. What is the first step that I just told you to do? Cross off the f of x and change it to a what? A y. So y equals 3x minus 2. Everybody okay? The second step was to switch the places of what? X and y. So x equals 3y minus 2. Everybody with me? Now you solve for y. I want to get y all by itself. Remember, we do the opposite of PEMDAS. SADMEP. Get rid of your subtraction and addition first. What do? I'm going to add 2. Good. So I have x plus 2 equals 3y. I'm still trying to solve for y. Divide by 3. And I get y equals x plus 2 divided by 3. And I have one more thing to do. How do you say, look, Mrs. Meadows, I just found the inverse. Perfect. F negative 1 of x equals x plus 2 divided by 3. If you do not put this notation, f negative 1 of x, I promise you I will take a couple points off. Now, some people are so great, and you guys are like, oh, I just really like to check my work. You can kind of, for the most part, check by comparing your original to your inverse, because inverse is opposite of each other, correct? Yeah. So in your original equation, in that original equation that we started with, we multiplied, you guys agree with me, we multiplied by 3 and subtracted 2, right? Yeah. Look at the inverse. We divided by 3 and did what? Added 2. You should be able, when you get your answer, you should be able to look at the original and go, oh, okay, yeah, opposite, opposite, opposite. That make sense? Yep. We okay? Yep. Okay, good, good, good. All right, skip this one for right now. We'll come back to it. I have a whole bunch here. You guys don't have these on your notes, so go ahead and take a picture of these for me. All right, algebraically, we're going to solve all of these problems. You guys are going to get real good at it. All right, first thing I do is cross off f of x and change it to a, okay, so y equals, there's a lot going on in this problem. That's okay. We have to remember a lot of our algebra skills, our computational things. After I cross off f of x and change it to y, what's the next thing we do? You absolutely have to do this step, guys, because if you don't, you're not going to find the inverse. You have to switch the spots of x and y because you're switching to find the inverse. And now we just use our algebra skills, our SADMEP, get rid of subtraction and addition first. So what am I going to do? Add 3 to both sides. Perfect. So we're going to add 3 to both sides. I have x plus 3 equals 2 times y plus 7 squared. Agreed? Okay, I'm still going to use SADMEP. I'm still trying to get my y by itself. So our subtraction and addition we got rid of. Now we have to get rid of division and multiplication. I'm going to divide by 2. Perfect. Divide by 2. So I have x plus 3 divided by 2 equals y plus 7 squared. Very good. I'm going to actually take the square root. Now, guys, what happens when you put the square root on top of something? It does cancel on the right-hand side. What do I have to put in front of my square root on the left-hand side? Plus or minus. You only do that, guys, for an even root. If you have a cube root, the 5th root, the 7th root, then you don't. But if you have an even root, like the square root, the 4th root, something like that, you have to put plus or minus. So this cancels out. So I have plus or minus the square root of x plus 3 divided by 2 equals y plus 7. What's my last thing I have to do? Subtract 7. Now, some people, does that 7 go underneath that square root? No. You can either write it as -7 plus or minus the square root of x plus 3 over 2. That's how I would prefer it. Or someone is like, can't I just write plus minus the square root of x plus 3 over 2 and then -7? That's okay, but you have to make super duper sure that I know that -7 is outside of that square root. I think it's a better idea if you write it like this. Like this one. Right here. Yep.
The thing in the parentheses is supposed to be x because I'm...
So let's look. Let's compare our original to what we just found right here as our inverse. In my original, I was adding 7 right here, right? What am I doing in the inverse? There's a -7. In the original, I was minusing 3. What am I doing in the inverse? Adding 3. In the original, I was multiplying by 2. What am I doing here in the inverse? Dividing by 2. In the original, we had this whole thing squared. In our inverse, we have the square what? The square root. You're always going to be able to go back and find the opposites. Yes. All right, let's move to the next one. Let's look at number 2. Number 2 is much simpler than the first one we did. But all we're doing is just working on our algebra skills, guys. What is the first step? Let's get into the habit of doing the same thing every time. What's the first step? Cross off f of x and change it to a what? The y. Okay, perfect. Now what do I do with x and y? We switch their spots. So I have x equals y squared plus 4. And now I'm going to solve. I want to get y all by itself. So what do? Subtract 4 from both sides. Y squared equals x minus 4. Now what? Take the square root. When I take the square root, what goes in front? Plus or minus. So I have y equals plus or minus the square root of x minus 4. Is that my final answer? No. I have to change y to f -1 of x. That's telling me, oh, look, here is the inverse. X minus 4. List a question. No, tell me. All right, let's keep going. Look at this one. What's the first step? What do I do? Okay, we're going to cross off f of x. I'm going to change it to y. So y equals -5x squared plus 3. Now what? Switch the places of x and y. So x equals -5y squared plus 3. And now we solve for y. So how do I do this? Subtract 3. Great. So we have x minus 3 equals -5y squared. I'll do it this way, Alyssa, so I won't flip it till the end. I still want to get y by itself, so what do I do? Divide by -5. Kara, question?
No, I was going to say.
Okay. Divide by -5. Here, you can answer this one. So I have x minus 3 divided by -5 equals y squared. I got to take the square root. When I take the square root, since I'm taking a square root or a fourth root, anything that's an even root, what goes in front of my answer? Plus or minus. So I'm left with plus or minus the square root of x minus 3 over -5 equals y. How do I need to rewrite that so it's nice and pretty and it says here is my inverse? F -1 of x equals plus or minus the square root of x minus 3 divided by -5. Now some people say, am I going to get points off if I should have x, plus or minus and I don't have it? Yes. Are you going to get points off if you put the plus or minus when it shouldn't be there? Yes. You guys have to be careful with what you're doing. And then we can go back and look. In my original problem, do you guys see how you were multiplying x squared by -5? In the inverse, you were doing what? We're dividing by -5, right? In the original, we had x squared, and in my inverse, I have the square root, right? And then in the original, we were adding 3, but in the inverse, we're doing what? Subtracting 3. You can go back and just say, oh, look, it's the opposite, it's the opposite, it's the opposite. Let's scoot on over here. Becomes a little redundant, but that's good. We want to get into some sort of a rhythm. What's the first thing I do with f of x? I'm going to cross it off and change it to a y. I skipped a step there. So So 5 minus 3x divided by 2. Now what? Switch the x and y. So x equals 5 minus 3y divided by 2. Now some of you are going to say, can I just go from the first step, f of x equals, to the switching? Yes. Do you have to do this part? No. Do I think it's a good idea to do that for today and this weekend maybe to get into the habit? Yes. Do I skip that step? Yes, because I've been doing this for 18 years. You guys have been doing this for 18 minutes. So it probably is a better idea to take that extra step, but you know. All right, so we're solving for y. What's the first thing I'm going to do to get y all by itself? Yes, be confident with it. What do? Multiply both sides by 2. Good, we got to get that denominator away. So this becomes 2x equals 5 minus 3y. Great. Now what? Ooh, very good. Subtract the 5. So 2x minus 5 equals negative 3y. Now what? Divide by negative 3. You have 2x minus 5 divided by negative 3 equals y. Is that your final answer? No, my final answer is f, negative 1 of x equals 2x minus 5 over negative 3. Now let's look. Let's compare our original to our inverse. In the original, do you guys see how you had a positive 5? In my inverse, I have a what? Minus 5. In my original, I was multiplying x by 2. In the inverse, in the original, I was dividing x by 2. And in the inverse, I'm doing what?
Multiplying.
Good. And in the original, I was multiplying x by negative 3. And in the inverse, I'm doing what? Dividing. Good. Very good, guys. All right, you guys try 5. Go. All right, help me out. What's the first step in number 5? Okay, so y equals negative 2x plus 1 divided by 3. Now I'm going to switch places, right? So x equals negative 2y plus 1 divided by 3. Now what? Multiply both sides by 3. Great. So 3x equals negative 2y plus 1. Now what? Subtract 1 from both sides. So 3x minus 1 equals negative 2y. And then what? Perfect. Divide by negative 2. So you have y equals 3x minus 1 divided by negative 2, right? Is that my final?
No.
What do I need to change y to? F negative 1 of x equals 3x minus 1 divided by negative 2. Guys, please make sure to, when you're writing this, do you see the negative 1 next to your f? Is it huge? No. This, God bless you, is not the same thing. Look at what I wrote on top of my answer. That does not say f negative 1 of x. This is no bueno. Don't write it like that. Make sure that your negative 1 is teeny tiny. All right, let's scoot along. You guys are doing awesome. First step. Tell me. Go. Okay, change this to a y. Now I'm going to switch the places of x and y, correct? So x equals y minus 1 cubed plus 2. Garnell, what do I do next? You got it.
Which one?
I want to get y all by itself. What do I do with that 2? You can subtract it. Subtract the 2 from both sides. So I have x minus 2 equals y minus 1 cubed. How do I get rid of cubed? Take the cube root. Now, guys, when I take the cube root, that is an odd root. Do I have to put plus or minus? No. So you have the cube root of x minus 2 equals y minus 1. What's the last thing? Add 1. You're going to do the opposite. We're going to add 1 to both sides. Does that 1 go underneath our cube root? No. If I were you, I would just write y equals 1 plus the cube root of x minus 2. Could I write it as the cube root of x minus 2 plus 1. Yes, but what do you have to make sure that I know about that plus 1? That it's outside, it's not in there. So if I were you, I would write it like this. 1 plus the cube root of x minus 2. And go back and compare. Compare the original. In the original, we had a minus 1. In my inverse, I have a plus 1, right? And in the original, I had plus 2. But with my inverse, I have a minus 2. In the original, we were cubing that whole thing. In the inverse, we're taking the cube root. Reese, question. All right, look at the next one. Where are we at? Okay, number 7. We're going to switch the places of x and y. I'm going to change this to y, and then I'm going to switch places. So I have x equals 3 minus 2y to the 5th. So we're going to do what with that 3? We're going to subtract 3. Great. So I subtract the 3. I have x minus 3 equals negative 2y to the 5th. Now what? We got to get y by itself first. So let's divide by negative 2. Good. So I have x minus 3 divided by negative 2 equals y to the 5th. Chloe, now what do? We're going to do the 5th root. Perfect. Now, when I do the 5th root, guys, is there a plus or minus? No, this is just the 5th root of x minus 3 divided by negative 2 equals y. And then what's my final? Tell me, Kiara.
Oh, wait, no, I was
Quick. So I have f negative 1 of x equals the 5th root of x minus 3 divided by negative 2. If you did it the way that you're saying right now, if you were here, you had x minus 3 equals negative 2y to the 5th, right?
Yeah.
And then you took the 5th root.
Yeah.
That's not the same thing. Because what you're doing here is you're taking the 5th root of negative 2y to the 5th.
And then you have
So then when you do this, this would become divided by negative 2, which is different than this whole thing underneath the 5th root. You've got to follow that order of operations. I understand why you did that, but you've got to get y completely by itself. Super important. Good. All right, last one, and I want to talk about graphing for 1 second, and then we're done. All right, step number 1 that we've done 19,000 times today, and it's really good to get into the habit of doing the same thing every time. We change f of x to what?
y.
To a y. And then we do what with the x and the y? Switch their spots. So I have x equals negative y plus 2 divided by 3. Correct? Okay. So how do I do this? What do? I'm going to multiply both sides by 3. I actually am going to do one extra problem because I thought of something on your website. So I have 3x equals negative y plus 2. Okay. Now what? Subtract the 2. So 3x minus 2 equals negative y. Is y all by itself?
No.
Why not?
Because you have a negative.
There's a negative 1 in front of it. So what do I need to do?
Divide
Divide everything, or multiply, you're right, by negative 1. So this becomes y equals 3x divided by negative 1 is negative 3x. Negative 2 divided by negative 1 is positive 1. And I rewrite that as f negative 1 of x equals negative 3x plus 1. Very good. Oh, why'd I change it? I don't know why I changed it to a 1. It should be a 2. You're right. I was talking about my negative 1, and then I changed it to a 2. All right, side note, real quick. If you guys have something like this, let's see if I can make it up real fast. F of x equals 1 over x plus 3. All right, you want to find the inverse. Well, follow our same steps. So this becomes a y, right? Yeah? And then I'm going to change spots. So I have x equals 1 over y plus 3. All right, you might come into something like this on your website and you're guys like, wait, we didn't do anything like this. All right, let's think for a second. I want to eventually get y completely by itself, but it's in a denominator now. So I can't just multiply by 3 because y is together, right? So what do I have to do, Olivia? Multiply everything by the denominator, the y plus 3. So you do it on this side, good. And then you do it on this side. So you have y plus 3 times x equals 1, right? Now, we're still trying to get y by itself. So what do I do?
Distribute.
No, we don't even have to. We want to get it by itself.
Move the x.
I can divide both sides by x, right? So I have y plus 3 equals 1 over x. And then what's the last thing? Minus 3. I'm going to minus 3 from the whole thing. Just a fraction, no big deal. So you have f negative 1 of x equals 1 over x minus 3. Good job. Sure. All right, good job, good job, good job, guys. One more thing I want to do. I just want to talk to you real quick, and we're done. Yeah. Like I just said, when you're talking about graphing inverses, your x and your y values swap places. They don't switch signs. What happens to that is your graph will be reflected not over the x-axis, it doesn't flip down, and not over the y-axis, it doesn't flip left and right. It reflects over this line, which is the line y equals x, this diagonal line right here. Because your x values become your y's and your y's become your x, it reflects over that diagonal line. It's going to go from the top part of the graph to the bottom, or from the bottom right to the top left, something like that. It doesn't go over the x or over the y. It reflects over this line right here, which is called y equals x. Which, again, we'll get into graphing a little more later. We're going to focus this section on algebraic, but you guys did a really good job today. So your web assign